Ever wondered what would happen if you dug a hole straight through the Earth? Let's get started with a mind-blowing fact. The Earth's core is about 6,371 kilometers away from you right now.
Aha, Doodles.
The Earth's core is scorching hot, with temperatures soaring to 5,500 degrees Celsius, like a giant oven beneath our feet. The ground beneath you feels solid, endless. But what's underneath it? Grab a stick, start digging. Dirt flies. Deeper, deeper. Meet Russia's Kola Superdeep Borehole. After 24 years of drilling, it hit a sizzling 180 degrees C and called it quits. That's less than 0.2% of the way to the other side. Now, imagine drilling through that heat. It's like trying to melt through a gigantic metal furnace with a toothpick. Pretty tough, right? But here's the thing, it's not. The crust, the part we live on, is thinner than you'd think. Picture an apple. The skin. That's the crust, just 30 to 50 kilometers thick. That's it. The Kola Superdeep Borehole in Russia is a record holder, drilling down about 40% of the way through the crust. At that depth, thermometers hit 180 degrees C, hotter than your oven's self-cleaning mode, thanks to geothermal heat rising 25 degrees C per kilometer. The Kola team quit at 12,262 meters, basically the height of Mount Everest, but upside down. Now you're entering the mantle, where temperatures are like your oven on self-clean mode, around 500 to 900 degrees Celsius. You're now surrounded by rock that's as viscous as really thick honey, which is weirdly similar to what we see in Hawaii's lava flows. This is the mantle, a 2,900-kilometer thick ocean of rock that's not quite solid, not quite liquid. Think molasses. But instead of cold and sticky, it's 1,600 degrees and moving at the speed your fingernails grow. And yeah, it's slow. But over millions of years, this rock flows like a river, dragging continents with it. Diamonds, they are born here, crushed under pressure so intense, carbon atoms lock into perfect crystals. But here's the kicker. No drill has ever touched this layer. We've only tasted it through rare volcanic eruptions. You're now at the Earth's core mantle boundary, a whopping 2,250 kilometers down, where things start getting really, really hot. You're sinking into the mantle's asthenosphere, where temps reach 3,000 degrees Fahrenheit, like a giant furnace. You've reached the outer core, a scorching sea of iron about 2,250 kilometers thick, where temperatures soar. But here's the twist. It's not just sitting there. It's moving. Vast heat from the inner core rises, cooler metal sinks over and over, like a giant, invisible blender. And that motion, it's the reason you're not getting fried by solar radiation right now. Because swirling liquid metal creates electricity, and electricity creates a magnetic field. Think of it like a planet-sized electromagnet, one that's been running for 3.5 billion years. No power outages. No maintenance, just a churning sea of metal keeping life on Earth safe. You'd hit the Earth's core, a scorching iron-nickel alloy, around 6,371 kilometers down. Pretty wild, right? You step off the churning metal river and suddenly, wham! The ground beneath you isn't liquid anymore. This is Earth's inner core, a solid ball of iron and nickel, packed tighter than a subway car at rush hour. That's hotter than the surface of the sun. Imagine trying to bake a pizza in under a second on Mercury's sidewalk. But here's the paradox. It's solid. Not liquid. Not gas. Solid iron, even though it's screaming hot enough to melt anything. The secret. Pressure. 3.5 million times what you feel at sea level. That kind of squeeze doesn't just push atoms together. It locks them in place like Lego bricks. No wiggle room. No escape. Just a perfect, glowing crystal the size of the moon. And somehow, that unmeltable heart is what keeps the whole planet's magnetic field alive. Turns out, the hottest thing on Earth is also the thing that holds it all together. That core starts just 2,900 km down, about the distance from New York to Los Angeles if you took a wrong turn at the center of the planet. That inner core's spinning faster than your favorite TikTok trend, about 0.3 to 0.5 degrees per year quicker than Earth's surface. Now you'd hit the lithosphere, the outer shell of the Earth, and its crust would get way thicker and hotter. At just 30 kilometers down, the weight of the rock above is like stacking 10,000 Eiffel Towers on your head. The heat is so intense. It's like baking cookies in a 1,000-degree oven, and that's just 30 kilometers down. You'd reach the Mohorovičić discontinuity, or MOHO, a 5-kilometer thick boundary that's like a superheated cosmic welcome mat. That's not rock. That's liquid iron, hotter than lava, and it would dissolve you faster than sugar in coffee. Okay, but let's pretend for a second. What if you actually could dig straight through? You start at Earth's surface, about 5,150 miles to the other side, with gravity pulling you down. That slow elevator feeling lasts about 3 km, until you pass the Kola Superdeep Borehole, humanity's deepest oopsie at 12,262 meters, where rocks got so hot they giggled and turned to plasticine. By 120 km down, you're free-falling at 1,600 km/h, faster than a cruising jet, and the rocks around you are hotter than a pizza oven's self-clean cycle. That's faster than a bullet. And yeah, you'd feel every second of it. Suddenly, at 3,000 miles deep, you'd hit Earth's liquid outer core, like diving into a sea of molten iron where your toaster would melt in seconds. Gravity flips. Now you're climbing against 3 million atmospheres of pressure, like doing pull-ups in a subway car packed with elephants. If you don't grab the edge, you'll just keep going. Back and forth. Forever. Total trip time, about 42 minutes. One way. You'd be moving so fast, the rotation of the Earth would make you miss the exact opposite point by about 1,600 km. That's faster than any rocket we've ever built. You'd be falling for about 42 minutes, which is roughly the length of a super long podcast episode. The Earth's gravity is pulling you back, but you've got too much speed. You'd hit around 18,000 miles per hour, almost as fast as the space shuttle in orbit. You'd essentially be in a crazy, high-speed, low-drag free fall, like a skydiver without a parachute, only much, much faster. You'd hit speeds of around 38,000 kilometers per hour, which is crazy to wrap your head around, right? Turns out, Earth's density is the reason it's that exact number. You'd end up about 1,800 miles off course, roughly the distance from New York to Rio. But here's the kicker. Where do you even land? You'd pop out at the antipode, the exact opposite point on Earth. Problem: most land antipodes are ocean, like 95% of them. Spain's antipode, the middle of the Pacific. New Zealand's, a field in Spain. Australia's antipode is actually a spot in the Atlantic, near Spain and Portugal. Talk about a long detour. You'd emerge in the middle of the Atlantic, roughly 1,000 miles west of Portugal. Talk about a surprise destination. You'd have traveled over 12,700 kilometers, which is like circling the Earth at the equator about half a time. You'd now be approaching the Earth's core, where temperatures are so hot they'd melt lead like it's ice cream on a summer day. You're now closing in on the core, where gravity pulls you down with a force about 2.5 times stronger than at Earth's surface. Pressure's so intense they'd crush a submarine like a soda can. You'd hit temperatures like those in a blast furnace, around 6,000 degrees Celsius. By the time you reach the Earth's core, that molten iron core would slosh around like a giant, angry smoothie. One sip, and your tunnel turns into a 3,500-kilometer-wide lava lamp. Even if you swapped your shovel for a diamond-tipped drill, you tap out at 12.26 km. China's new 15 km deep borehole will still leave you 6,356 km short of the other side.